Hey everybody, so my name is Byron. Today we're going to learn a little bit about the strategy pattern and how to apply it in a practical situation. And the hope is that you can start applying this to your code immediately. You can probably think now about or after this session, you'll be able to think pretty clearly about times in your code where you've got this kind of thing going on, and you can apply these principles pretty quickly and easily, and hopefully all you'll need is this session to give you a kickstart in the right direction. If nothing that I say makes sense, then the main thing I want you to hear is what is the pattern, why or when would you use it, and then I want you to hear just at least the domain name of a website where you can go to find out more resources. Because if nothing else works about this entire session, you can't hear a word I say. As long as you know what is the pattern, when you should use it, and where to find information about it, then you're golden. You'll be able to go from there on your own. But so the purpose of the example is just to try to drive it home a little bit more and to give you some concrete examples of how to use this. Does anybody have times in their code base where you've got large if structures or switch structures where you've got lots of different branches, lots of different ways that your code could go? Anybody want to speak up and describe one of those?
Yeah, we had a couple of those working in Vortex. We had to decide how to process a specific message we received based on a series of attributes. It could be a data processing message. It could be just a simple message. We had around 20 different types of messages, and yeah, we had a big structure that we had to use like a big decision structure to use to determine how to process that message.
Cool. Anybody else? That's a very good example. Anybody else?
I remember the one in Acklen. So for the ones that don't know, the Acklen had an integration with, I guess it was Duola. And basically Duola was calling our API with a lot of different type of requests. So we have just a really big switch where we're doing like, in the case that is this answer to this and that multiple times, and it grow a lot, I think even more than 100 lines, that function, I remember. So yeah, it was really big and hard to read.
Yeah, so, and I think that this is a pretty common thing. In fact, conditional structures are a foundational, pivotal piece of any programming language. You can't get very far in a programming language without some sort of decision-making system. So switches and ifs are very important. But as I'm sure you guys have experienced firsthand, if the if gets too big, if it has too many conditions in it, if a switch has too many conditions in it, then it can get really difficult to manage. And if you're trying to unit test such a class with one of those conditional structures, it can make the unit tests extremely complicated to maintain and keep going. Also, if you've ever tried to implement or tried to adhere to solid principles, one of the principles in solid principles is O. The O in solid is for open closed principle. And the principle basically says that a code base or a piece of code should remain open to extension but closed to modification. And so if you've got a large switch, and like here I'm showing you a hospital with medical codes. Well, as you can imagine, we've only got 4 medical codes in here right now, or really 3. But in a regular hospital, you're going to have hundreds of medical codes and probably even inventing new medical codes along the way. So it's kind of like you can't have open closed principle in a class like this where you're constantly going to be having to come back to this class to add more and more and more codes. And worse than that is the more you have to come back to this class, the bigger the switch gets, the more difficult it is to maintain, the more problems you're going to end up having. So So when you have a situation like this where you've got a switch or an if or any kind of conditional that you have lots of different branches or ways to go, then you can think strategy pattern. So there it is. If there's nothing else if you can't hear anything else in this session, if you just hear that part and remember strategy pattern, anytime you see a conditional structure like this, then you're golden, because then you can just Google strategy pattern in your language and you'll find plenty of examples. So any questions about at least the when to use it before I launch off into some examples? Alrighty, silence is acceptance. So that must mean that everything I said was perfect. So here we go. So I have here a hospital, and you can see here that I've got a constructor with several different dependencies, and this is going to be a pretty gory, bloody kind of demonstration. We've got a bone saw, we got an injector, we got a tooth puller, a painkiller, and an emergency room. So apologize for those that have squeamish stomachs. I hope you've had a good lunch. I hope it's been at least an hour ago. So here I've got a method on this class called treat illness, and it needs to collect different procedures, because the hospital, of course, is going to have to charge for all of these different medical procedures. So the first priority is to realize the medical procedures, and then the second priority is to charge for them. So for right now, we're only worried about performing these medical procedures. And if you've ever worked in a medical system before, you know that they typically work on codes. And so I don't know exactly what the codes are, but I know that at least in some hospitals, they are 4-digit codes or 5-digit codes. So we're going to go with 4-digit codes for right now. But this could be easily 10-digit codes, doesn't matter. So this method is taking in a medical code, which is the procedure code. It's a more like an umbrella procedure code. And then it's got a default or a conditional argument called is emergency. So if this procedure happens to be an emergency, then they'll say this is true. Otherwise, it'll default to false. By the way, this is C# in case somebody's not recognized some of these structures. So here I'm going to create an instance of this treatment outcome, and then I'm going to return that. And then in the middle, I'm going to, based on the switch, based on the medical code and whether it's an emergency, I'm going to do these things. So this is not horrible code right now, but as I said, this particular fictitious hospital is going to have thousands of medical codes, each with its own set of procedures that need to be run for each medical code. And so this class, just by virtue of doing it this way, is not necessarily breaking open-close principle, but it is setting us up to break open-close principle. So open-close principle is one of those principles that you almost never count it. It almost never counts when you actually break it, because that's usually kind of like you have to do the thing. Open close is one of those principles that you count when you have set the developer up for breaking it. So by doing it this way, we are almost guaranteeing that we're going to have to break the open close principle to keep on maintaining this code. So here is a place where we can definitely refactor this, and we can apply the strategy pattern. So, and I'll stop occasionally with a little bit of silence just to let you all, if anybody has any questions, this is a good moment. But and then I'll keep on going just in case nobody's got any questions. Any questions so far?
No questions, but to me it also seems like it is breaking the single responsibility principle, because we are actually treating, well, you have treat illness, right? But there are like multiple illnesses. It's not like only one, I think. Seems to me, right? Or perhaps I am like...
Yeah, I think you're right about that too, because this class has to know, this treat illness method has to know what exact procedures apply to this medical code, and that these procedures go with this medical code when it's an emergency. So yeah, I think you're right about that. Any other comments or questions?
Nope.
All right, cool. So we'll keep on going. So what do we want to do here? We want to refactor this code so that it is adhering to our principles and is more maintainable. So a few things come to mind. Anytime you're looking at a switch or an if structure, you can just kind of look at the code inside, and very often these blocks of code could be extracted out to their own method, for instance. So I could go ahead and do that. I'll do this, and we'll I'm not sure what to call this yet, but let's see. We'll say do procedure. I think somebody's dying in this library that I'm in. Do procedure, and then I'll paste the number. So there, I've extracted that as a method, and then this is going to be. I'll extract this one out as a method also, and this is going to be do procedure. Whoops. Do procedure. Procedure is a proven fact that when people are watching you type slower with more mistakes. So this is going to be do procedure emergency, and then I can extract this one out as a method, and this will be do procedure 1292. So I've reduced the line count for this, but I still haven't reduced the responsibilities. Each one of these still has to know how to deal with it, each method, and the class itself has to have these procedures, and you still have a pretty hefty constructor where you don't always need, like if you're going to pull a tooth, you don't always need a bone saw, right? You don't really. That's not something that you want to see in the operating room when you go in for a tooth pull. Fun fact or fun story. The first time I went to the Hospital Seguro in Tegucigalpa with Pamela, she went in with a toothache, and it was just a toothache, right? And this is before we went over to Honduras Medical Center. And so she went in with a toothache, and the line was full because we got there last, and the line was full just for the people looking at your tooth. And so they said, well, so that you don't waste the trip, why don't you go ahead and get in this line? We're okay, that's fine. What's this line for? It's for tooth pulling. And so the option was to not waste the trip. We should go get the tooth pulled. So they needed this application. So and then that was our last trip to the Seguro. So I was like, no, might end up with a leg amputated. Okay, so we still have a problem, but we have at least like pulled these out to their own little places. These methods now represent pretty much everything that needs to be done as far as this procedure. So now I want to apply the strategy pattern. Before I do that, I'm going to run all of my unit tests. And just to make sure that I don't like screw everything up, I've got 85% coverage. I had 100% coverage before I did this switch right here, which is interesting. Kind of makes me want to run them again. I'm not going to keep on going back to the coverage, but I didn't want to mess things up. So I do have at least all my tests passing. So when treating a broken tooth, then we're going to pull the tooth. And so the test is basically just saying, the result is should have this pulled tooth number 20 string as the outcome. So we want to make sure that our tests are not failing after this. So then what I'm going to do, I'm going to maybe move this out to its own strategy. So there are ways to extract methods using like the resharper tools to actually move it into a class, but I'm not that fancy. Oops, I need to use the right keyboard shortcuts. I'm not quite that fancy. So I'm going to just create a new class up here. So this is going to be a public class tooth pulling strategy, I guess. I'm not sure. And this will have, we need to create an interface that all of these can adhere to, or we could use inheritance, but I like interfaces a little bit better. So this will be an I procedure strategy, just to create something. And it's good to use the name strategy when you're using the strategy pattern. That way it alerts future developers that you're actually using the strategy pattern. So here I'm going to do procedure outcome. Procedure outcome is the thing that the other one was outputting. So I'll say do procedure. I'm sure there's a better name, but I'm not sure.
Are we ready?
And
It's not.
I'm not sure what else is going to go here, so we'll start with that and implement the members, and I'll return null for right now, just to kind of get me started here. So then I'm going to say strategies is new list of I procedure strategy, and do that, and then I'm going to give it a new tooth pulling strategy just so that it's in there. Go ahead and create a field for this so that I've got those strategies. And then here, I can actually just say, I can say strategies first.
Okay, we're not gonna check.
Dot do procedure. And I'm not sure what else needs to go in there except that I think I said that I was going to paste this code in here. Yeah, except I wanted to do it here. Okay, so this goes here then. Right. So so this should be the we can say what is this outcome thing? I can't remember. Treatment outcome. So then I'll just make this one right here return take a treatment outcome. So that I've got that. And then this particular strategy is going to have all four of those in the dependencies. So I'm going to go ahead and add them here. And I guess I don't need one of these. This is the tooth pulling strategy. I pulled in the wrong one. I'll just got to rename it. So this is going to be the left arm amputation strategy. Left arm amputation strategy. Isn't that horrible? Okay, so then I'm going to create a constructor, and you're probably wondering, why isn't Byron injecting dependencies? And the answer is that's a different lesson, not today's lesson. For today, we're just going to new everything up in here like cowboy coders.
So, like you talked about, like the little thing that you can show your paper on when you go.
And let's see, one of these I don't need, which is the tooth puller. Yeah, so get rid of the tooth puller. What's nice about this is that I only need the dependencies that I actually need for the actual procedure. So then this right here needs to return it's not going to return a procedure outcome. This is going to be a void. All right, so this right here should be void also.
No.
Everybody with me? Or am I just speaking to myself?
Yep, we're here.
You with me? Okay. All right, so this, I just need to set the argument here. So this is going to be a treatment outcome. Okay, so I think we're almost there, almost done with the build errors. I need to add my outcome here. Okay, and then I'll move some of these things out to their own files. So this one can go out to its own file. And then this guy can also move out to its own file. All right, so now it's telling me that the emergency room is not necessary, which is interesting. It's because I used the emergency room here. So I can actually now, I can refactor this guy out completely. I don't need that dependency anymore, which is nice. But I need to change this to a left arm emergency amputation strategy because it's specifically for emergencies. So, okay, we're getting there. We're getting there. So then I'm going to do. Some of you guys are going to be like, don't copy paste, but I'm going to copy paste because I want to make sure that we get through this, and I'm pretty sure I know what not to leave behind. So like here, I don't need the emergency room. This is going to be a regular emergency. This is going to be a regular arm amputation, which for me, any arm amputation would definitely be an emergency, but I'll leave it there. And then this guy, I can go ahead and move it out. And back up to the hospital completely. And so now, yeah, I should have the ability now to add in a new left arm regular amputation strategy, which means I can go here and I can replace this one. Do procedure outcome. Whoops. Okay, and then I can remove this one. So the idea here is to kind of one by one go through and remove the things that you don't really need anymore. All right, so I'm just gonna check real quick, make sure I'm not breaking anything. Go into my unit tests and run all of those. All right, everything's still passing, so that's good. So then I'll go ahead and do one more here, or another one. So I'm going to say a new. This is going to be a new right leg amputation strategy. Okay, and then create that type, and implement, and paste. Okay, so I just need the painkiller. I did the wrong one. Okay, rename. This is tooth pull strategy. Okay, so I just need the painkiller and the tooth puller. So I'll copy both of these guys. Create myself a constructor and add them down here. My keyboard's not always obeying me. Okay, so that guy can move out, and I can remove this. And so, now I can't keep on doing the same thing I was doing. I was going strategy first, strategy last, and that's not going to always work, especially since now this is not last anymore. This is now, this is probably the middle one. Now this is the last one. So it's not going to pass all of my tests. Some of my tests are going to fail now. Yeah, there they go. Yeah, I got a failing test here where the this procedure is not working anymore. The non-emergency amputation. So what am I going to do here? Anybody want to give me any ideas of how to select which strategy?
I would do like a map where you could pass like what you're getting, the medical code, and it will return you the strategy object.
That is very valid, and what you're talking about there leads us to implementing something called the factory pattern. And very often the strategy pattern goes right hand in hand with the factory pattern. And so, but in this case, I'm gonna avoid using the strategy pattern. I just want to use pure strategy. Sorry, I said something wrong. I want to avoid using the factory pattern. I just want to use the strategy pattern.
Mhm.
So, is there a way that we could select the strategies based on their code, or based on some whatever? I guess we're using the code in the is emergency. How can we select them based on their ability to handle the situation? Okay, it's a very abstract concept, but let's go ahead and implement this last one, and then we'll see what happens. So this is going to be the right leg. Create that type. Yeah, be thinking, if you come up with an idea while I'm implementing this, then go right ahead and tell me. I can actually take these out completely now, and put them right here. Okay, so I've got that one implemented. And it would help if I could navigate. Okay, I want to move this out to that one. And I still have this method, so I'll remove that as well. And now this is going to be just another, this is actually now the last strategy again. So every time we add another one, we mess things up even more and more. All right, so I'll tell you what I would do in this case. We've got a lot of strategies to choose from. They all perform a similar task, but they're doing it in different ways. We just need to know how to select them. So how about if we allow the strategies themselves to understand whether or not they can do the procedure. So what I can do is I can go to the interface here, and I can say Boolean can do procedure, and I can I can take in the medical code, and I can pass in the so I can pass in those things right there. Well, then what I can do here on the tooth pulling strategy is I can return is emergency is false. Let's see. Actually, it doesn't. I'm not sure. We'd have to figure out whether or not, or ask the client whether or not there is a difference between an emergency tooth pull and a non-emergency. But it's not an emergency, and the medical code is equal to, and I can't remember. We'll go back to the hospital and see what it is. I believe it's 1292. So 1292 there. So then if I go back to my hospital, I could refactor this entire switch now This is one of my favorite parts. I could kind of use some of the array manipulation stuff that I learned from JavaScript, and I can say matching strategies, and that is going to be strategies dot where x goes to x dot can do procedure medical code is emergency, and then first dot do procedure outcome. Now, and actually, I don't need the variable at all. And then this is even telling me I can. Yeah, nice. Okay, I should have known that. So there, I can actually remove this entire thing now because of that little refactor. So now this hospital, with the exception of this that I've got going on here, I am able to. This method is completely open close compliant. Like there's almost no reason that I can see, or there is no reason that I can see why somebody would need to come back and modify this method, at least. Now, to add new strategies, we would need to add them here because we're not doing injection. But there are ways to overcome that using a constructor injection. We can inject a list of these into the constructor, and then our IOC container would populate it for us, and we wouldn't have to have this list right here, which would be really nice. And it would make it more testable. So while I refactor these guys right here, what questions might arise? What questions might come up for you guys?
Your last solution to identify which procedure to execute is a little bit like the chain of responsibility design pattern. Isn't it?
Well, so remember, single responsibility is more of a principle to follow, kind of like a guideline, a rule. And in a design pattern,
I said chain of responsibility. Chain.
Oh, thank you. So, can you describe chain of responsibility a little bit?
Chain of responsibility is like, for example, you have several processes and you give a request, which that request is going to be passing through all of those processes, but none of them is going to be executed unless the request is for them. Like you have a ball, you pass it to, let's see, to Ferenc. Ferenc, if the ball is supposed to be thrown for by him to someone else. If it's not, then Ferenc is going to move it forward to someone else, let's just say Jimmy, and so on until it gets to the point that someone gets the ball and says, oh, wait a minute, this is a ball that is supposed to be thrown by me. So that's where the execution happens. I don't know if that makes sense.
Yeah, it does. Can you hear me?
Yes, I do.
Yeah. Yeah, so chain of responsibility in that case, I need to study that design pattern obviously more, but it sounds like what that pattern is talking about is actually passing from one class to another class to another class. Like in this case, each procedure talks to the next procedure, and they keep on passing the baton one after another. Okay. In this case, it's the context, the hospital is looking at each one. So the strategies don't know about each other, and they don't communicate amongst each other. But the hospital knows about all of them.
Okay.
So I guess the difference there would be who knows about who.
Makes sense.
Okay, and this one is the.
Byron?
Yes, go ahead.
I was wondering what would happen if you couldn't find a strategy that matches the code. What would hospital do?
What do you think should happen?
Well, in my mind, I think that will return like a null, and once you try to call the procedural, raise an exception or something like that.
Right. Um, the so okay, you need to ask the client because the client is the one that knows really what should happen if there are no procedures. So they may say, well, okay, we need, if that means we're missing or somebody's using a procedure code that's incorrect, we need to send an email to so-and-so. Or they may say, well, we want the system to ask them if they want to create a new medical code or whatever. And so then whatever they say would then dictate what we need to do. So if they say, well, we want to prompt the user to create a new code. Well, then in this case, this class or this method needs to somehow alert its calling code that it couldn't find the right strategy, a matching strategy. So that might be an exception. It might be a specialized treatment outcome. So like this is a regular, just a treatment outcome class, but we could create a derived type called invalid treatment order. And so then later on, I don't know whether we've got, we can just have procedure options always null or always empty. And then later on in your code, you could have something that checks to see if it's an invalid treatment order and then alerts the correct manager.
Okay, got it.
But it all depends on what the user really wants to happen when you run out of strategies. Okay, so I'm wondering if all my tests are still passing now that I've refactored this out. I got a failing test, so let's see how hard this one is. It should diagnose the problem. This is an emergency, so this is the emergency patient, the emergency room, and 8372 with true. So I would go to my left arm emergency and is emergency. It's true. See, that's why the unit tests are the bomb. Okay, so that one's right, and then this one. 8372. So then if I go to the this one, left arm amputation strategy, this one should not be emergency. There we go. That way this one passes. Okay, so this strategy pattern, this little method here is kind of cheating. There are probably other ways that you could do this. For instance, if you were to use the factory pattern, you could probably get rid of this method altogether. You wouldn't need this because then you push you push this logic off onto another place. You could also do different kinds of things like with generics to help select things. You could use convention over configuration and name the class by a certain convention, so that you say left arm amputation, and then that kind of eventually you map these codes to left arm amputation, and then just go and find a strategy that matches. Lots of different very valid ways to select which strategy you want to choose. So one of the big benefits to using strategy pattern, especially in a case like this where we had a growing switch statement, a growing conditional structure, is the testing benefits. So right now, each one of these tests is the system under test is the actual hospital. But really, at this point, the hospital is only doing one thing. It's doing it well. It is picking which strategy, and it's dispatching or deploying or doing the strategy. So this hospital at this point only needs one spec. It only needs one test, maybe two, maybe for like the happy path, and then one for the sad path, and if it can't find a strategy or something like that. But we definitely don't need all of these, and we definitely don't. The tests don't necessarily need to know anything about broken tooth or dead arms or whatever. So these tests could be refactored as well, and so I'll refactor at least one of these, depending on how much time we have. The idea would be to basically redirect this test to point at the strategy that it's talking about, because we don't really need a test for the hospital that deals with this medical code. We would rather do this directly to the corresponding strategy. So I'm gonna start by changing the soot here. Actually, no, I'm gonna start a new test because this test is still valid. So we'll start here. Actually, I'll start a new test like this. And when pulling a tooth, it should do what? It should pull the tooth, and it should also give painkiller. Painkiller. So my soot is now a tooth pull strategy. And then I'll go ahead and create this field. And so now my system under test has a do procedure, and I'm going to pass in a treatment outcome. And so my result, I think this is void, so we don't need a result. And so now really what I want to do is I want to check the procedure, the treatment outcome. So I'm going to back that out to a field. And then I'll be able to use these right here to test my output. So my treatment outcome is actually, I'm going to rename it to result. No, I'm going to leave it the way it is. It sounds better this way. All right. So now those are, now both of these tests should still pass. So I'll go ahead and run this test. I'm pulling a tooth. Okay, so there I've got a test now that's basically testing the same things, but it's going directly to the strategy instead of going to the hospital and then passing in the code and things like that. Now, I need another spec here for when deciding if tooth pull is right. So then it should be able to do the procedure. And so my system under test is still the same. So I'm going to copy this guy. And so this time I want to test the can do procedure. And now I'm going to pass in 1292 and false. It's not an emergency. And the result is going to be a Boolean. And so I just want to say the result should be true. Okay, so then I've got two new tests. Once I've got both tests in place, then I can safely remove the test about the hospital. I could also, if I were injecting the dependencies, then I would actually be able to test the hospital itself without without the specific codes and things like that. But since I'm not injecting any of those things, I kind of have to have them. But you see here, this test is very specific about the strategy. This test up here, it seems kind of simple right now. It's not too bad. It could get really, really worse. Like this setup right here could get really, really unwieldy as you add more hospitals, especially if you're doing dependency injection. Even if you're not doing the dependency injection, if you're newing up your instances right there in the constructor or as you need them, that could get really hairy also, because every time you new up the hospital, it's going to go off and new up all these things that you may or may not need. So even though this test is fairly simple right now, it could get really, really ugly at some point. So these tests for these strategies are going to pretty much always be about this simple. So over time, as this code base grows, this design is going to be a lot more future-proof. Okay, so I'm going to pause just for a little while and see if you all have any comments or questions, complaints, reclamos, whatever you guys can come up with.
You just touched me.
I think it was a clear, at least for me.
Yes, clear.
So I'll ask it a different way, or I'll ask a different question. Can you guys, anybody, think of a time when you might use the strategy pattern, maybe even as early as tomorrow? And maybe give me an example.
I want to answer that, but I will let the others answer it. So.
Hey, Bonilla, go ahead because everybody else is being bashful.
Okay.
Yeah, go for it.
All right. So yeah, as you mentioned, I would say smell, or when we should think to apply this is whenever we see like a switch, a really big switch, or we think that it's going to grow. That might be like a good starting point to really start thinking that should we apply a strategy pattern? Is that like correct answer?
Yeah,
I'd
yeah, I
say
totally
that
agree.
it's not only for switch statements; it's also for the ifs and if and else statements as well. So
Yep,
also
that's
for,
right.
logic operators, then
Mhm.
strategy pattern works.
Yeah, I agree.
I was also thinking about whenever you are going to have different implementations of something. So let's say that you want to build like an application that can run on every type of database. So basically you will have to apply a different strategy for each database. For example, a Postgres strategy, a Microsoft SQL strategy, and so on.
Yeah. About that, so the strategy pattern is it's not always, but it's typically to do with runtime selection. So when you've got an application where you're having to select which way to go at runtime based on user input or based on conditions in the system, you don't know until runtime when you're actually going to select them. And so I think technically the database idea is a form of strategy pattern, but it's just typically it's a runtime decision. And so like a database selection, I would place into more of like an adapter pattern kind of category, because as a programmer you're going to choose which one you want, and you might not switch databases too often.
Right.
I totally agree with the switch or the for each, any kind of conditional structure. So how about if we play it this way? Does anybody have a switch or a for each that, or a for not for each, an if, sorry, an if else structure with more than two conditions, more than two branches?
Case and some uh, if else condition that we could have used the strategy pattern.
Yeah. So do you, Ricardo? Do you have a specific example of your project just finished, but got a specific example of a for each that you could imagine? Sorry, not for each. An if else or a switch structure that you could imagine refactoring to this?
Yes, for example, we have something called Duola. Duola is a bank transfers application. Um, and we have several responses from Duola. From each response that we have from Duola, we have to take an actions. So on our code, we have, if the response from Duola was this, we are going to do this action. And for every response that we have a condition. And I think we could have implemented something like this.
Yeah, and what I typically try to coach people on is if as they call it a rule of thumb. I'm not sure why in English, but a rule or a guideline is anytime you've got more than two branches in a conditional structure, it might be, not every time, but it might be a candidate for a refactor like a strategy pattern. So I know some of you guys are not speaking up right away, but you know, if you're working in a system that's making decisions based on conditions or user input or things like that, I'll bet you've got situations in your code like this where you are where you're dealing with potential open close principle violations, potential single responsibility violations, and you're maybe hoping for a way to refactor that to where it can adhere to those principles, and then also, you know, have better, cleaner code, more testable. So anytime you see a conditional structure with more than two or more than three conditions in it, think strategy. It very well could save the day. So thank you guys for your participation. Next time we'll do something a little bit different, or probably very similar, but we'll tackle a different pattern, and we'll show some more code examples, and hopefully we'll all get to learn something. So for the next 2 weeks, starting today, it is strategy pattern week. So try your very best to find places where you can apply strategy pattern to your code, so that we can drive this home. And if you feel encouraged by your progress, then feel free to share examples of your use of strategy pattern in the developer channel, and everybody will get to learn from that. So thanks for being with us. Have a nice dinner, nice afternoon. Buen provecho. See you guys later.
See you later.